to look at differentiation. Well, product rule and quotient rule as it relates to differentiation. All right, so we still have these rules that we have to follow. All right, and we have here the product rule and the quotient rule, right? Product rule, product relating to multiplication. So UV, and this is the formula for it. I like to put V first to make it look similar to how the quotient rule is written. Addition is commutative, 1 plus 2 is 3, 2 plus 1 is 3. Doesn't matter the order, all right? So that's why I like to put this first. So V, you write on V first, and you differentiate U with, that's why you get du dx, you differentiate in U with respect to x, plus U, then you write on U first, then you write on U after, and then differentiate dv dx. So it's like you write it on V, you differentiate U, and then you write it on U, well, plus, always plus, this is important, then you write on U and you differentiate V. The quotient rule, quotient means division, so you have U over V. You write on V first, right? This one you have to write on V because you see the subtraction here. 2 minus 1 is 1, 1 minus 2 is -1, it's not equal, right? So you write on V first, you differentiate U, du dx, minus, always minus in this case. You write on U after, right? You must write V first, differentiate U, and then write on U and differentiate V, right? So with respect to x, and all over V squared. So whatever is V, that's what you'll be squaring. All right, so let's take a look at these questions one time. So I have here, let's say y is equal to, you don't have a y here, but I can say, okay, y is equal to 5x squared sine 6x. So we want to differentiate. Now, how can we identify if this is product rule or quotient rule? Now, because you cannot simplify this, you cannot multiply x squared by sine x, and you get one simple expression, right? We have two, we have an x situation here, we have another x situation here. So it cannot be simplified to get one expression, right? So we have to apply product rule in this case. Now, I will apply product rule to this entire 5x squared, right? Some people may apply product rule to the x squared alone and then call this one V, and then multiply 5 by whatever is in the brackets. I find that is a little extra work that I'll run away from. So I will say U is equal to 5x squared, and I'll say V is equal to sine 6x, right? And then I'm going to apply the product rule UV, which is this formula here. So I like to write the formula first. So I will say dy dx is equal to V du over dx, right? Product rule always plus, and then you have u dv over dx, right? So what that means is you write on V is sine 6x, and then you differentiate U. If you differentiate in 5x squared, it's already other multiplied, always multiply. When you differentiate 5x squared, you will get 10x. All right, 5 2s are 10, 2 minus 1 is 1. So you get 10x. Plus, you write on U, so U is 5x squared. And then you differentiate V, right? The differential of sine 6x. If we have to remind you, differential of sine x is cos x. So if you differentiate in V, which is sine 6x, right, you will get cos 6x. And it doesn't stop there. Then you multiply by 6y. Remember, differential of sine 6x is cos 6x. And then you have to differentiate the 6x. Don't forget that. When you differentiate 6x, you will get 6. close bracket, continuing. So once, let's say I see this line, I would assume the student correct, because this line is correct. The next step is to simplify, and simplifying is very important, because how you simplify your work can make your life easier or harder. And if there's a proof that you have to prove one side is equal to the next, you have to be careful how you're simplifying it, because you have to shape your work in such a way that you arrive to the answer that the examiner wants you to arrive to, when it's showing that one side is equal to the next side. So to simplify, I'll just put my 10x in front. As I said, that's my preference. If somebody put, okay, the answer is 10 sine x, sine 6x by x. No, that's correct, but I just like to put the x in front. Plus 5 6s are 30 x squared cos 6x, and that's the answer. That's the answer. So we applied product rule here. So let's look at this one. This one here, we have sine 3x over cos 4x. Now, once you kind of reduce it to make your life easier, and you have one simple expression like sine 2x, or you have x cubed, right? One simple expression, you have to apply the quotient rule or the product rule. In this case, because it's in the divisor, you have to apply the quotient rule. So this is u divided by v, right? So remember, the quotient rule is u over v. That's the, when you differentiate, and you have v du dx minus u dv dx over v squared, right? So that's the first thing I'll write. I like to write my formula first. dy dx equals right. Then you substitute. So v is cos 4x. So I'm writing cos 4x. Let me zoom this a little bit. And if I have to differentiate u, so the differential of sine 3x, just to remind you all, the differential of sine x is cos x. So the differential of sine 3x is cos 3x. And then you have to differentiate 3x, which is 3, close bracket, minus, I write down my u now, u is sine 3x. And then I'm going to differentiate cos 4x. Differential of cos x is negative sine x. If you recall here, differential of cos x is negative sine x, right? So the differential of cos 4x is negative sine 4x, negative sine 4x. And you differentiate 4x, you get 4. So you always remember to differentiate this after, all right? And that is all over v squared, and v is equal to cos 4x squared, right? You write this 4 a little better than that. Now, after this, you simplify. Simplifying is important, all right? So I put my 3 first. I can leave the cos 4x. I just like to write things in a certain order, you know. So I will have 3 cos 3x cos 4x. When you're multiplying two different signs is a positive, pay attention to that. Put my 4 first. Sine 3x sine 4x, and all that is over cos squared 4x. Now, to simplify this here, you have to put the square by the cos. You're not squaring 4 and x. This is not equal to cos 4 squared x squared, or 4 squared is 16, cos 16 x squared. That is wrong. you have to put the square by the cost. This is equal to this, not that. So try not to make that mistake, all right? And this here is your answer, right? This here is your answer for part B. So for this question, I can use the normal way. I can use product rule, and I could use quotient rule, and I should get the same answer for all of them, all right? So for the normal way, I can use laws of indices and say, oh, okay, when you divide in the same variable, you subtract the powers, right? So it's x to the 2 minus 5, and that is x to the negative 3, right? And then if I want to differentiate this with respect to x, dy dx is equal to negative 3, because negative 3 times 1 is negative 3, right? X to the minus 1 from 3, negative 3, and you have negative 4. So dy dx is negative 3x to the negative 4. You can leave that as the answer right here. If you want, just to elaborate, I can write this as well, right? I can write that. Now, let me look at another way. Let me look at the product rule, right? So I can say, well, okay, y is equal to x squared multiplied by x to the negative 5, right? So if I switch the position of the denominator, and I don't need to put the multiply sign, right? X squared, x to the negative 5. Let me leave it. Let me leave it, right? And I can apply the product rule, right? This is u, this is v. Dy dx equals all right, there's a product rule right here. I always write my formulas first. V, write down v. V is equal to x to the negative 5. If we differentiate u, so if I differentiate 2x, I'll get, if I differentiate x squared, my mind thought of the answer one time, I'll get 2x. Differential of x squared is 2x plus u, which is x squared, and I differentiate v, which is negative 5x to the negative 6, right? So if I differentiate v, negative 5 by 1 is negative 5x to the negative 6, negative 5 minus 1 is negative 6. And I simplify. So when you're multiplying for laws of indices, same variable, you add the powers. So 1 times 2 is 2. If I multiply x to the negative 5 by x to the power 1, add the powers, negative 5 plus 1 is negative 4. All right, let me do put plus just yet. When I'm multiplying different signs, I get a minus. When I'm multiplying 1 by 5 is 5. When I'm multiplying x squared times x to the negative 6, same thing, multiplying same variables, you add the powers. So 2 plus negative 6 is negative 4. Right? Notice we have the same variables, x to the negative 4, x to the negative 4, 2 minus 5, but you could add and subtract like terms. 2 minus 5 is negative 3. And you write back x to the negative 4, and you can simply write it like this. Right? We realize these two answers are the same, and we'll talk about 3 of them afterwards. I can also use, from this, I could also use quotient rule. So we have y is equal to x squared divided by x to the power 5. Mind you, you're supposed to get the same answer, right? So here we have u divided by v. Dy dx is equal to v du over dx minus, and that is all over v squared. So we have v, which is x to the power 5. To differentiate u, we have 2x minus we have u, which is x squared. We differentiate V, we have 5x to the power of 4, right? All over V squared, which is x to the power of 5 squared. All right, now let's simplify it. We have 2x to the power 6 because 1 times 2 is 2. Laws of indices, you add the powers, x to the power 6 minus 5 x to the power 6. So 1 times 5 is 5. Laws of indices, x to the power 6. All over, we have x, don't need to put the brackets, to the power 10, right? 5 times 2 is 10, laws of indices as well. Well, laws of indices here. So we continue in, we have 2 minus 5, because we have the same variable, the same term, so we could add or subtract like terms here. The like term is x to the power 6. So 2 minus 5 is negative 3. X to the power 6 divided by x to the power 10. Now remember, when you're dividing same variables for laws of indices, we subtract the power. So we have negative 3x to the 6 minus 10. That is equal to negative 3x to the minus 4. And we know this is equal to negative 3 over x to the plus 4. All right. So this is equal to this, which is equal to this. So I did all that to simply illustrate. If you have a question like this, choose wisely. Simplify and differentiate it the normal way. Right? Differentiate. Do not go down this road, which is the product rule, or this road, which is the quotient rule. Right? You have to exercise wisdom. Choose the most efficient and effective way to do it. All right. So that's it for product rule and quotient rule with relation to differentiation.